Mrs. Serkis again, and today we're going to talk about mixtures, which will be helpful when you get to your chemistry class. So we'll talk about the concentration of a mixture of two solutions, we'll understand neutral and pure solutions, and we'll find the unknown volume in a mixture. Since I only have 15 minutes to do this, it might take 2 videos. So the first thing we're going to talk about is understanding when we mix two things together to make a third thing. Now, we are only going to look at the kind where you are mixing two solutions of the same main ingredient and you end up with a different concentration. So it's always going to be the same main ingredient. So when you mix the two things together, what you need to recognize is that the total volume of the mixture is the sum of the two volumes. And that's, I hope, kind of obvious. Now the concentrations, the two mixtures, assuming they are different concentrations, because if you're mixing together the same concentration, well then the resulting mixture has the same concentration. If they're two different concentrations, the mixture will have a concentration that is stronger than the weaker of the two and weaker than the stronger of the two. So another way of saying that is whatever the lower concentration is and the higher concentration is, the mixture is going to be in between. And the other thing we need to know is that when we are considering the concentration of the mixture, you can think about it in terms of the partial volume of the pure stuff. So if it's an acid solution, the amount of acid that's in the pure stuff plus the amount of acid that was in the pure stuff that was in the first solution, the amount of acid from the second solution is going to add up to the total amount of acid or whatever the pure stuff is in that mixture of the solutions if you had made it from scratch. So let's go ahead and do some problems where we are mixing some stuff together. So I'm going to start with, so we're going to start with exploring the idea of mixing two things together. So if we have 800 milliliters of a 12% acid solution mixed with 200 milliliters of an 8% acid solution, well, the easy thing to pick out is that the total volume of the mixture is going to be 1,000 milliliters. Because 800 milliliters of the first plus 200 milliliters of the second adds up to 1,000 milliliters. Now, as far as what the concentration is of that third solution, we know it's going to be somewhere between 8% and 12%. It's not going to be 8%, not going to be 12%, and because it's not equal amounts, it's not going to be 10%, but it's going to be somewhere in between those two. So what we're going to do is we're going to explore, okay, if we had to make this solution from scratch, a 12% acid solution and 800 milliliters of the solution, then we would need 12% of 800 is the pure acid. So what we're going to do is we're going to take 12% of 800, and there's different ways of doing that. The fastest way to do it is do 0.12 times 800. Another way of thinking about it is do is over of equals percent over 100. So the percent over 100, that's the easy part. 12 over 100 equals x over 800, because the of is the total volume and the x is the volume of the acid. So cross multiplying, it's 100 times x equals 12 times 800, and that's going to be 100x equals 12 times 800 is 9600. Divide everybody by 100. And we get x equals 96. It would have been a little quicker, I think, to say, well, 0.12 times 800 is equal to 96. So either of those two methods is acceptable. Any way you slice and dice it, that means that the way we would have created this 800 milliliter solution would have been by starting with 96 milliliters of acid and then add enough water so that your total volume is 800. So that's what I drew here, is the little dots here represent you starting with that much acid. In this case, it's 96 milliliters of acid. And then you add, let's see, 800 minus 96 is 704 milliliters of water to make this mixture, assuming that there's no chemical reaction that would require a change in volume. And we're not going to get into that because this is a math lesson, not a chemistry lesson. I'll be happy to guide you towards a chemistry instructor if you want more information about that. Okay, so the next thing we're going to do is we're going to say, okay, how much pure acid would it take to make 200 milliliters of an 8% acid solution? So if you had to start from scratch, you would take 8% of 200. I'm going to go ahead and take the shortcut here and say 8% is 0.08. So 0.08 times 200 is 16 milliliters. So if you think about it this way, and I'm going to highlight them in blue here. So 96 milliliters of acid is from the 800 milliliters of the 12% solution. And you needed 16 milliliters of solution to make this 8% solution. That is 200 milliliters. 200 milliliters of an 8% solution contains 16 milliliters of acid, and the rest of it is water. So that's going to be, what, 184 milliliters? That's up here, that's the water, and the 16 milliliters is here. Now, if we were going to make the mixture from scratch, we would start with 96 plus 16. 96 plus 16 is 112 milliliters of pure acid. So that's what these dots represent here, is that there's 112 milliliters of pure acid and the rest of it's water, and it adds up to, we knew it was 1,000 milliliters because of mixing these two up. So to find out what the concentration of this is, well, it's 112 milliliters of pure acid and a total of 1,000 milliliters of solution. So 112 divided by 1,000 and then convert it to a percentage by multiplying by 100% gives us 11.2%. And as predicted, that is somewhere between 8% and 12%. You can't mix together an 8% and a 12% solution and end up with something that's weaker than 8% or stronger than 12%. So that's just a mental check to say, okay, the one that results has a concentration that is between the other two concentrations, but we can't just like do some kind of simple math and get to that concentration. Okay, so the next problem we're going to do is similar, but now we are introducing the concept of a neutral solution. So we're going to find the concentration of the resulting solution when 500 milliliters of a 16% solution, so this is a 16% solution, is mixed with 300 milliliters of a neutral solution. When you see that word neutral, that means 0%. That means it doesn't have any of the main ingredients, so that's 0%. So the math that we need to do is we'll start with 16% of 500, and that gives us the volume, the partial volume, meaning the volume of the pure acid. So 0.16 times 500 is 80 milliliters of pure acid. How much pure acid is there? Well, that's pretty easy to see. It's 0. So what's going on here is the total volume of the mixture. Well, 500 plus 300 is 800 milliliters total volume. And if we were making this identical solution from scratch, we would need the total amount of pure acid from the two solutions. So 80 plus 0 is 80 milliliters of pure acid. So the concentration is going to be 80 divided by 800 and multiply by 100% to turn it into a percent, which gives us a 10% solution. And this makes sense to me that it's 10% because we had a 0% solution and a 16% solution, and 10% is stronger than a 0% solution, but weaker than a 16% solution. So hopefully now you understand the concept of how we get to, how we mix two things together and end up with a third thing. The calculations basically have to do with, well, if you had this thing and this thing separately, or if you made it from scratch. So the raw ingredients to make this plus the raw ingredients to make this add up to the raw ingredients that you would make for that. So you don't have to like actually separate out those raw ingredients to do the math and use it. All right, so now let's consider what do we do when there is an unknown volume. So how many milliliters of a 12% solution should be mixed with 500 milliliters of a 20% solution to obtain a 17% solution? So the first thing we want to do is to make sure that we have the percents in the right places. So looking at those three percentages, if you put them in order from smallest to largest, it goes 12%, 17%, 20%. So the one that's in the middle is the 17%. That must be the one that's over here, because that's the only combination that'll work. You can't end up with a 12% solution when you mix these two. You can't end up with a 20% solution when you mix these two. This is the one that's in between. That's the one that goes off by itself. All right, so the other two are the 12% and the 20%. And the one that I see first in the problem is 12%. So I'm going to put the 12% here and the 20% there. It doesn't really matter what order you put them in. Let me go ahead and put this in the same levels here. So we got the 12% first, the 20% second, so that's on the row with the percent strength. Now the total volumes, what do we know? Well, 500 milliliters goes with the 20%, so 500 goes here. Now, how many milliliters are there? So we have a choice of putting our variable x either here or there. I'm going to choose to put it here because that's going to answer the question. When I solve for x, it's going to answer the question, how many milliliters of the 12% solution? So I'm going to put the x there. Now here's the part that perhaps is less intuitive, and that is, what's the total volume in the mixture? Well, we don't know what x is, but we know that when we add these two together, that's going to give us the volume here. So I'm just going to leave that as an algebraic expression, x plus 500, and of course that's going to be in milliliters. Now what's the partial volume? Well, this is going to be 12% of x is 0.12 times x. 20% of 500 is 0.20 times 500. And so, because remember, the percent times the total volume gives us the partial volume. So we're going to do the same thing here. We're going to use 0.17 times x plus 500. Now, what I also like to recognize is that this partial volume plus this partial volume is equal to this partial volume, because remember, we're talking about the ingredients. This is the pure acid that comes from the 12% solution. This is the pure acid that comes from the 20% solution. Because we cannot create or destroy matter, the only way it's going to get into this third solution is if it came from those other two. So our equation is 0.12 times x plus 0.20 times 500 equals 0.17 times x plus 500. Now this is a perfectly acceptable equation to use, but because it's all percents, that means per 100, so you can think of each of these as a fraction. 12 over 100 times x plus 20 over 100 times 500 equals 17 over 100 times x plus 500, which seems like a crazy idea, but roll with me. This is going to work, because what's going to happen is I'm going to do the same thing to both sides of the equation, which is to multiply and distribute by 100. So here, this is going to be 100 times 12 over 100x plus 100 times 20 over 100 times 500 equals 100 times 17 over 100 times x plus 500. And what that does is it cancels out the hundreds, and we end up with the much easier equation, 12x plus 20 times 500 equals 17 times x plus 500. So what that does is it gives us, we can actually jump from this step with the x's and the percentages down to here. So we didn't even have to do this, this, or this. We can just jump right to this step, and it makes it a lot easier. I'm running out of time, so I'm going to go ahead and finish this problem in my next